Hello, everyone, and thank you for watching. Today, I'm presenting my project on Vygotsky's cultural historical theory, specifically looking at how a materialist understanding of his work can reshape mathematics education. My approach comes from both academic study and 11 years of teaching math in Detroit, where I've had to think carefully about how concepts develop for students whose experiences with math are often procedural, fragmented, or disconnected from meaning. This presentation focuses on three things: Vygotsky's historical and philosophical grounding, how mediation functions in mathematics, and what this looks like in my own classroom practice. One of the main challenges in math education is that students often experience mathematics as a set of steps, tricks, or rules handed to them without any explanation. Teachers work hard, but the system itself tends to push procedural coverage over conceptual development. Vygotsky gives us a different lens. Instead of seeing learning as something that happens internally and individually, he positions learning as a historical and social process. That means students develop understanding through tools, symbols, and cultural practices that humans have built over generations, such as here. For me, this theory matters because it helps explain why certain teaching approaches fall flat and why others, like one's rooted in activity and what Vygotsky calls mediation, leads to deeper mathematical insight. So, what is cultural historical theory? There are four major ideas I want to highlight. First, Vygotsky argues that learning is always mediated. Students can't learn only directly through experience. They can learn through cultural tools like diagrams, graphs, algebraic notation, and even language itself. Second, instruction leads development. This is one of the most misunderstood aspects of Vygotsky. Students wait to be ready for concepts. Rather, instruction brings them into new forms of thinking. Third, students begin with spontaneous concepts formed through everyday experience and move towards scientific concepts, which are organized, abstract, and part of humanity's accumulated knowledge. Finally, all thinking is shaped by social cultural context. This means that the classroom is not neutral. It is a site where cultural tools and histories shape cognitive development. So these four ideas form the foundation for everything else in the presentation. So to understand Vygotsky's work, we have to ground it in the early Soviet movement when the new state needed a psychology that aligned with Marxist materialism. Vygotsky worked alongside a massive literacy campaign, new forms of schooling, and a cultural push to understand human development not as a purely internal and private journey, but as something rooted in work, language, and social life. With colleagues like Luria and Leontiev, he viewed cognition as a product of human labor and cultural development. Tools such as mathematical symbols, writing systems, and diagrams are not neutral. They are forms of historical memory. This grounding is important because modern American interpretations of Vygotsky often strip away these materialist roots and turn him into a generic socio-cultural theorist. Restoring the historical context gives us a much clearer sense of his actual intentions. So, between spontaneous and scientific concepts, this distinction is foundational. So, spontaneous concepts come from daily life. A student may know what a big jump or a steep hill looks like, but that doesn't mean they understand slope. They have experiences, not concepts. Scientific concepts, by contrast, are not discovered by the child. They are the product of centuries of human development. On the next slide, you'll see Euclid, Descartes, Newton. These concepts must be taught deliberately through tools and sequences that make their structure accessible and visible. Our job as teachers is to help students use their spontaneous impressions as raw material. Through mediated activity in math, such as graphing, modeling, comparing, symbolizing, students reorganize these impressions into scientific understanding. This framework becomes incredibly powerful in mathematics, where nearly everything is abstract. So, from a Vygotskian perspective, curriculum is not simply a list of standards or just a pacing guide. It's a deliberately organized sequence of cultural tools. Every mathematical idea has history, algebra, geometry, calculus. And that history matters because it reveals the logic of how concepts came into being. When curriculum ignores that logic, students get a disjointed learning experience. The algebra-based physics class is a good example of this. Physics in modern day as a subject was built alongside and with calculus. When we remove that history, we remove the conceptual backbone. And this is why Vygotskian theory calls for us to think about curriculum development not as just content coverage, but as the reconstruction of the historical pathways of ideas. So we can see how these mathematicians built on each other. And that's where Vasily Davidov comes in. He took Vygotsky's philosophical theories and built an entire math curriculum grounded on these principles. So his innovations include reorganizing math so it starts with measurement and relationships rather than just counting, and prioritizing theoretical thinking, also creating activity structures where students generalize before formalizing, and then treating diagrams and models as essential mediators. Davidov's work demonstrate what it looks like to actually ground schooling in Vygotsky's theory. So while most American classrooms use constructivist or procedural approaches, Davidov makes it clear that Vygotsky demands something else, a deliberate restructuring of the subject so that concepts emerge in the right order. So what does that mean for teachers? In a Vygotskian classroom, the teacher is not simply a facilitator. The teacher is the organizer of the learning environment. Learning begins with structured activity, something for students to act on, whether that's a graph, a model, a survey, a simulation. Students explore with their spontaneous impressions, but only is the starting point. The key moment is when the teacher introduces conceptual tools that allow students to reorganize their thinking. And that is the heart of mediation. So instead of students constructing mathematical ideas from scratch, they're appropriating the conceptual tools that have been developed historically and make them their own through activity. So I'm going to have some examples from my classroom now. Um, in my IB Algebra 2 class, I began teaching an activity, and I'm using the transformation of functions as my first example. Um, Students first begin by manipulating sliders, stretching and compressing graphs, and shifting them left to right and to match target images on a Desmos activity. This gives them a concrete, intuitive sense of transformation before they're exposed to the formal language and algorithm. The key moment each year is when they realize that a vertical stretch, and a horizontal compression are linked, but they see it visually before they have a formula or how to do it in a function. So only after this activity happens, then do I introduce the formal notation and structure. So what's important is that order, the external action, the noticing of the pattern, then the conceptual generalization, and then formalization. And this mirrors exactly what Vygotsky describes. Another example is in my statistics classroom. When I teach surveys, without teaching them about the formal things, I begin with student-created surveys. They write them without any instruction first. So they can begin to uncover issues like biased wording, unclear categories, sampling errors. Rather than lecturing about bias abstractly, we anchor the concept in their actual mistakes. Their spontaneous ideas, or what they think a survey is, becomes the raw material for scientific concepts. When I later introduce terms like response bias or sampling error, these concepts have meaning because they are tied to that experience. And this is why Vygotskian mediation works. It builds scientific concepts on top of real activity and not just rote memorization. My last example from my classroom is my uses of trigonometry essay. The trigonometry essay Has students researching how trig is used in real fields like acoustics, aviation, medical imaging, astronomy, oceanography, they have a number of fields I can pick from. The assignment expands their conceptual world. Many have never heard of a lot of these professions. The new knowledge changes what trigonometry means to them. They begin to see math as a cultural tool, which is a set of ideas developed through human labor that they're going to be entering. This is a direct application of Vygotsky's belief that learning is participation in the historical development of human thought. To summarize the entire theory and its application, learning happens through cultural tools, not in isolation. Curriculum must follow the historical structure of ideas, not arbitrary sequences. Instruction is deliberate mediation, not passive facilitation. And students develop scientific concepts through activity, reflection, and guided conceptualization. The goal is not procedural performance, but theoretical understanding, the ability to explain, generalize, and apply mathematical ideas. Vygotsky gives us a framework that honors both the cognitive development and the intellectual history of mathematics. So I'll close with a statement that guided my paper and my teaching. A learning is complete not when students reproduce procedures, but when they can use the tools independently, explain concepts in their own language, and apply them in their daily lives. And this is the heart of Vygotsky's cultural historical theory and the heart of what I aim for in my classroom. Thank you.